So checking this question from November 2023 exam, which is on the STEAM calculations, our STEAM generation, we are going to see the guys that this was actually a repetition. We have talked about this type of a question before. We've discussed this type of a question. So you see that it was just a repetition, just one or two things that you need to consider. But if you're someone who have been watching these videos, you see that it's one and the same. But let's see. All right, so that's question 3. As we can see, we are asked, we are being required to use what? The STEAM table to determine the following. So these calculations here, they are supposed to be derived, they're supposed to be determined from the STEAM table. We are supposed to use the STEAM table as an assistant. So the STEAM table is there as an assistant. So let's check the first question, 3.1. The specific enthalpy of steam. Take note. The specific enthalpy of steam at a pressure, this one, and a temperature of. So we are used to determine the following. What are we determining? The specific enthalpy of steam. So when you're given the specific enthalpy of steam, how is the steam given? We need to know. Is it wet steam? Is it dry steam? The moment that we are given the specific heat capacity of the superheated steam, then we are knowing, okay, this steam is what? The superheated steam that we are talking about. So the specific enthalpy they are referring there is of the superheated steam. And since we have the specific heat capacity, remember also when you're dealing with steam, when it is wet steam, they will mention that it's wet steam, 1. 2, they will give you the dryness fraction, or they will give you a percentage of how wet it is. Take note. If they wanted you to actually calculate the enthalpy, the specific enthalpy of wet steam, they are supposed to give you something that consists of the wet steam. It's either the dryness fraction, which is our X, which is our dryness fraction, or they can give us maybe is 10% wet. Then we know that the enthalpy there, the specific enthalpy, is H wet. But the moment they just say, they just give you, calculate the specific enthalpy. The reason why I'm saying this is that they might not give you this one, which is the specific heat capacity of superheated steam. This one, they might not give us this one. They might not give us this. Why? There is an information, or there's another part where the pressure and the temperature can correspond direct on the superheated table, on that part of the superheated steam, where you can determine H sup given pressure and temperature only. When you are given that, you can find H sup from the pressure. You check that column, it is the pressure, and also it has the superheated steam. So you'll be having T sup there and the pressure. But the moment they give us a pressure like this and a temperature like this, and they also give us the specific heat capacity of the superheated steam, it means this information that we have does not correspond there. We do not have exactly a pressure of 2050 and a temperature of 25, where they do correspond direct. We do not have that from our superheated steam table. We do not have that. So that's why they give us what? The specific heat capacity of the superheated steam, so that we go back and use those normal steam table. We are no longer using the superheated steam table. We are now using the part of what? Of the superheated steam. So be careful about this question. It can be an easy question in your site like this, but they might not give you this specific heat capacity. You must know that. So we have got a pressure there. Let us quickly take what we have. So there is 3.1. So as I explained, that the H sup that we are going to have there cannot be determined direct. from the superheated steam table, but we can use the steam tables, meaning to say we are going to use Hg plus Cp for the superheated steam into the difference that we have of the superheated. This is T sup minus Ts. This formula we must be given from our formula sheet. Let me show you. Okay, okay, let me just here. We have got this one. If you check the way that they gave us here, it's given as H is equal to Hg into this. So this is H sup and this is Cp for the superheated steam. The change in temperature there, it's T sup minus Ts. This Ts is for the saturation temperature. We talked about this one is for saturation. So these two, they are supposed to be taken from the pressure that we are given, these two. We take them from that pressure that we are given. We are given at a pressure of what? All right, look here. I'm thinking that is on another page. It's from the same page here. At this pressure of 2050. All right. So at that pressure, that is 2050 kilopascal. What is the value of Ts there? And what is the value? Because yes, we have got T sup, but this T sup does not help us anything because from the superheated steam table, you won't have that value corresponding to anything. So that's why they gave us this specific heat capacity. That's the major reason. So let's use our steam table. So we are not going to use the superheated steam. You use this one for the for the steam. This one where we put pressure Ts. There's another one where there's pressure here. Then you see here it will be written superheated steam. It will be written superheated steam. The other is on the same booklet, but just different pages. So there are two different things. This one is the steam table, then that one is the superheated steam or a table. So this is it here. We need under the pressure, remember we need the pressure of what? 2050 there, kilopascal. We are going to need Hg and we are going to need also Ts, which is our saturation temperature, like I said before. So our Hg there, because of these guys, I'll keep on shifting and shifting. I just want you to see where you take this. Under the pressure there, you see 2050, it's here. 2050, it's this one. So you must go along the 2050, like that. All right. So along this, we now need Ts. Remember, we need the saturation temperature. Ts, it's measured in degrees Celsius, this one. So the first one, the first value that we have there is our Ts. So meaning to say under that value, you are going to obtain what? Ts. Under this value down here, this value there is your Ts, which is 213.6. I want you to use your steam table, or you can use your textbook. Your textbook, it has that. All right. So we saw the value for Ts. You do the same thing for Hg, because we also need Hg for the dry steam. This one for the dry saturated. This one is for the dry saturated steam in kilojoules per kilogram. So we need this value under that pressure. So that's how you take your values, guys. I think this one now, we are so much familiar. Some of us that are new, that is what you're going to do. You need a steam table to do that. So to take this value. So we have, guys, the value of Hg. We have the value of Ts. So we are going to substitute these values into our formula. We saw our values. All right. So let us substitute them. So it means H sup was going to be given as Hg. So this one is from this pressure, which we saw that it was 2,797 plus the specific heat capacity. This one is the one that we are given. We have it. That is 2,1 kilojoules per kilogram Kelvin. So that's 2,1. We are given this. Also T sup we are given. That's the temperature. It goes together with the pressure. At a pressure, there is a superheated pressure, a superheated temperature that corresponds there. It is together with the pressure. But this one is for the saturation. It's for water. When it is water, saturation temperature, that's like water. So it's like temperature for water. We are subtracting. Remember, it starts from the economizer. We move from the economizer to the evaporator to the superheater. So the TS, it's when we are at the economizer there, like the saturation temperature. So at the pressure of this, we saw that our TS there was 200, and this one, it was a value that we got from our steam table. Remember, it was 213.6. So be careful on that part. This one and this one we are given. We must be given these ones, all right? So that means you are going to find H soup from there. So that's your H soup, which is going to be 2946,94, which is kilojoules per what? Per kilogram, kilojoules per kilogram. That's it. So that's how we can calculate this, or we can have these values. So that was our question 3.1. So this one, all the formulas, I think we talked about these formulas we referred, or maybe just need to do it like, okay, as a topic by topic, maybe like subtopic by subtopic. All right. But let us, for the meantime, be guided by our formula sheet. The volume now in cubic meters per kilogram of the superheated steam, that is V soup, of the superheated steam mentioned in question 3.1, mentioned before, assume that N is equal to 1.3, which is the index of compression, amount of expansion. So we're given N, and we are supposed to calculate V soup. So N is given as 1,3, and the question is calculate V soup from 3.1. What is it that we calculated from 3.1? We calculated H soup. Do we need H soup to calculate V soup? Yes. Check our formula here. It says that V soup is given as, we've got our formula. So I'm going to explain this formula, what it means. So you see that we need that. So it is stating that to find V soup, the formula is stating that this is going to be N minus 1 over N into, that is going to be H soup minus 1941, everything over the pressure. So this is our index of expansion. Then the pressure is the boiler pressure, the boiler at the superheater, at the condition that we had here. What was our pressure? 2050, when it is the superheated steam. So everything is there. So we're just going to calculate this. So that's V soup is equal to N. We are given 1,3. So don't be afraid of these questions on steam. These are the easiest questions on steam. Don't be afraid. Everything you have, you just have to take your information. You are done. H soup. So your H soup, you already calculated that. That is the only part where you need your formula. And like I said, I'm going to have another question where you do not need to use this formula. You have to just use direct your superheated steam table. But already we calculated this one. So we're just going to substitute. So you see, that's the easiest subject, this one, because you just have to know your formulas, substitute properly, and also know to manipulate. Yes, that's another thing about your power machines N5. Know how to manipulate the formulas sometimes when there's a need. All right, so the pressure at the superheater conditions or at the boiler condition is given as 29. Because remember, I say the pressure at the boiler is the same pressure as the one that we have at the superheater condition. So that was 2050. So that's it. We are going to obtain V soup, and that V soup is going to be in cubic meters per kilogram. So that is going to be 0,113 cubic meters per kilo. That's it. That's a V soup. So like I said, this type of a question, I really know that I talked about this before. Maybe it was for the members, I don't know, but I remember everything. Like they just took like everything. They just changed the values, but we had reviewed for those who wrote before November exams. Okay, 3.3. They now need us to calculate the internal energy in kilojoules per kilogram. of the superheated steam mentioned again in 3.1 before. So how do we calculate the internal energy? All right, let's hope we have got this formula, but if we do not have, I'm going to talk about this formula. But they're supposed to give it this one. Yes, look how they gave us this one. It's only that, guys, you see the way they're writing, but that is it then. This is the formula for the internal energy. So the internal energy is given as H, which is the enthalpy, minus the pressure times the volume. Let me explain this formula. Let me explain this formula. That's the formula that you use to calculate what? Internal energy. But they are saying it's for the superheated, and as you can see, it's for the superheated. Mentioned in 3.1, we can see that exactly it is for the superheated. So this is what you're going to do. From that formula, this is question 3.3. It is stating that the internal energy is equal to H minus PV. So when we are talking about the internal energy, if we see that, if we saw that there is an N, which is the index of expansion, meaning to say this is going to be taken to another level. That is where we talk about this now. If you see after this, they are now saying the internal energy of wet steam is because the steam was taken from a certain pressure to another pressure. So because of that, this U, let us just call it U1, because it's a process from one stage to another stage. That's why we are given that N for expansion. Stage 1, stage 2. So this is going to be U1, which is at the superheated steam. So the H is the enthalpy there. We're talking about the internal energy of the superheated steam. So definitely this enthalpy is the enthalpy of what? The superheated steam. The P, the pressure, is the pressure at the first conditions, which is of the superheated steam again. Then the volume is the volume of the superheated, which is V soup. So you can write, yes, you can write this as, in short, you are supposed to actually write as U1 is equal to H1 minus P1 V1. But what is H1 representing? What is V1 representing? That is the most important thing. All right, so that's it. So the internal energy U1 is going to be H1, which is H soup, because we're talking about the superheated steam. So we're going to use, or to take, H soup. Our H soup there, remember we calculated 2, 9, 4, and so on and so on. So you're just going to substitute them. So this was 2, 9, 4, 6, 94 minus P1. Remember our P1 we were given, guys, that was 2050. Then V soup, we calculated V soup here. We got 0.113. So everything is there. Everything is there. We're just going to have our internal energy, which is going to give us 2,715.29. So challenge yourself to do as many questions as you can on steam calculations, steam tables, whatever that consists of steam. The boiler calculations, just challenge yourself. Whether there's a challenge or a question, let me know about that question so that we can try and talk about it together or refer to it about that question together. But that's it. So meaning to say we've got our internal energy for the, remember this one, for the superheated steam. Because we're going to have another internal energy after the expansion, which is no longer superheated steam, is now wet steam, which are the conditions they are now talking about here. If we check on 3.4, they are now saying here, 3.4, we are supposed to calculate the dryness factor. What is the dryness factor? The dryness factor is the dryness fraction X. So they are saying calculate the dryness fraction. The moment they talk about the dryness fraction, it means the steam is wet. We are talking about what? We are talking about wet steam. There's a certain fraction, a certain percentage of the steam being wet. So we talk of H wet. That is the enthalpy that, yes, the dryness fraction. So there, be careful. This one you're supposed to be careful, this question. They are trying to manipulate, to change those questions that we are used to. How? Okay, let's see this one. For a 2 kilogram of steam, so this is the mass of wet steam. That is wet steam now. Moment of dryness factor, the steam is wet. So we've got the mass of 2 kilograms at a pressure of, so we've got the pressure of 1,500 kilopascal, given the enthalpy of wet steam as there. That is where they were testing you. These 4 marks, we're going to obtain it. Here, they were testing you here. The enthalpy there of wet steam at, which is as 4,800 kilojoules. Is it how it is supposed to be given? No. Guys, let's be careful. You see, power machines, the units, if you just get mix of units there, our power machines, it affects us because it's all about the units. Let us go back here. Let's go back here. We calculated H sub there. It was the specific enthalpy of the superheated steam. We got what? Whatever that we got, it was kilojoules per kilogram. That is per given mass. It was because we are not given the mass in this case here. We are not given the mass of that steam. So the answer is supposed to carry kilojoules per kilogram. Kilojoules per kilogram, it means the mass is not been used. We haven't used the mass. No. We haven't used the mass. The moment, guys, take note, the moment you just multiply by the mass here, because the mass is in kilogram, it cancels the kilogram together. Your answer remains in kilojoules. So that's why you see this one here. Let us go back. Let us go back to our question. You understand me now. If you check here, they gave us not, okay, I wrote it this side. Okay, sorry for that. I wrote it here. I was about to write it actually. They gave us the enthalpy of wet steam, which is H wet. Originally, which was supposed to be kilojoules per kilogram. But now it's no longer like that. They gave us this as 4,800 kilojoules, not per kilogram, not per kilogram, no. Why? It is because of the mass involved. This one, we multiplied by mass to get this. Remember what I said? Kilojoules per kilogram times mass gives us kilojoules. It is equal to kilojoules. You have removed per kilogram. Per kilogram is no longer there. You have removed it by the mass. So what it means is that we cannot use this to calculate X. No, because the enthalpy that we know here, this one. Okay, let me explain this, guys. You understand me? H wet, which is equal to HF plus XHFG. I talked about this formula before. Okay, let us go back to the formula sheet for the recap. We see this one is just given as H. This formula is H wet. This one is for H wet, where X is there. So it's HF plus XHFG. This formula, this one, it is giving you not the answer in kilojoules, no. but it gives us direct the answer in kilojoules per kilogram. This is the basic unit of the enthalpy. The enthalpy, the basic unit of it is kilojoules per kilogram. That's the basic unit of enthalpy. So be careful on this one. So meaning to say, if it is the basic unit of the enthalpy, we need that. That is what we are used to. So what are we going to do? Let us bring it back. How? Remember, to get this kilojoules, we multiply it by the mass. So to get back to the kilojoule per kilogram, we have to what? To divide. We multiply to get the kilojoules. Now we want the kilojoules per kilogram. We're going to divide. So it means the H weight, which is 4,800 in kilojoules, once divided by the mass, which is 2 kilograms, it gives us kilojoules per what? Per mass, per kilogram now, mass. So that is the way, that is the case there. So it means the moment we have this, we are now having 2,400. So this will be 2,400 kilojoules per kilogram, which is the exact unit of measurement of our H weight, the enthalpy of wet steam. So it means this one can be used on this formula because we're now having the exact units. What made us not to use this one is because it is kilojoules. Here, this one is supposed to be kilojoules per kilogram. Unless we are to use mass here like this. Yes, I agree with you. You can use that. So I'm going to show you like this. Okay, let me explain that way again. If we're to use the mass, let me finish this one. So we're going to make X the subject. Remember, we need X then. So to make X the subject, we are going to substitute, we're going to transpose, or you can substitute everything. That one is up to you. You can substitute our H weight now in kilojoules per kilogram. Our H weight is what? 2,400. So this will be 2,400 there. 2,400 is equal to HF. So what we need now is HF. From where? Definitely we've got the pressure there. So we're going to use this pressure at 1,500. Guys, I think now you know how to take these values. But anyways, let us go back to the steam table. This is at 1,500 here. So you go straight at 1,500. You must take the value which corresponds there with HF. HF here and HFG. Remember, we need HF and HFG at 1,500. So HF and HFG, this is HF 845, HFG 1,945. So these are the values that I need there. These are the values that I need here. So we are going to have 845 here. We took this one from the steam table, 845 from our steam table. All right, plus X is the one that we are supposed to calculate. HFG, we saw this value for HFG. It was 1,945. We took this value again from our steam table. So that means we can calculate HF. We can calculate X. It's a simple equation now. Transpose this to the other side, we subtract. So this will be 1,555 is equal to 1,945 X. So to find X, simply divide by this, both sides. Simply divide by this, both sides. You are done. You are done, just like this. So this will give us our dryness factor or the dryness fraction of 0.799. All right, no units for the dryness fraction. Be careful, guys. The units there. If, let's say, you wanted to use that value as it is, therefore it means you were going to use the mass. This, because I explained here that to obtain kilojoules. It means you multiply kilojoules per kilogram by what? By mass. So it means for us to use this H weight in kilojoules, it means it was given like this. H weight is equal to the mass times HF plus X, HFG. This is where we multiplied by the mass. It means our answer becomes kilojoules, like what I explained here. Unless you understand this, yes, I agree with you. You can use the 4,800. So it will be like this now. 4,800 is equal to the mass. Remember, the mass is given as 2. So this is 2 into HF. We calculated, guys. HF, we took this from our steam table, 845 plus X. Remember, our HFG was 1945. So just divide by 2, or you can multiply by 2. It's up to you, guys. This is mathematics. It's in your hands. So this will be 2,400 is equal to this, which is 845 plus this 1,945 times X. So if you check this stage that I'm seeing here is exactly as this stage. So that means definitely we are going to have the same answer. That is what it means. We are going to have the same answer. So if you wanted to use that value as 4,800, you have to consider the mass. All right? So that's about the weight steam. Let's move on to the weight, about the same weight steam here. So that is, here, let me take these answers, guys, because the way I'm seeing this board might just react. And it causes a lot of problem if it does so. So remember, we calculated the dryness fraction. Maybe we're going to need this, I do not know, 0.799. And also I talked about H weight, that instead of using this, we can use that one, 2,400, which is kilojoules per kilogram. This is now per kilogram. The mass is already what? Mass is already used. Mass is already there. All right. Now, with the information that we have calculated, they want us to calculate 3.5. The volume in take note, in cubic meters, not cubic meters per kilogram like the previous one, this one. It was because the mass was not there. The moment that you involve the mass, it cancels those per this, per that. Is it per kilogram? Is it per what? Whatever that you're given. The actual measurement that we're supposed to have there, or the actual unit that we're supposed to be there, was supposed to be cubic meters per kilogram. But because the mass is involved, it cancels per kilogram. You are left with just cubic meters. So there, the question needed us to calculate the volume of the wet steam, V wet. All right, so it follows that V wet, we can calculate this. Remember that V wet is the product of the dryness fraction and VG. Provided that we have in this, I think we have got this formula, but they gave us in another way. Let me check. All right. All right. So if you check the way that we're given here, they wrote it as X is equal to VM over VG. The VM here is for V wet. So it means V wet can be given as X times VG from this formula. So be careful how you are going to manipulate it. So this is V wet, it's X times VG, all right? But what is important is that the VG there is the volume of the dry steam, meaning to say is the volume at the pressure, this at 1,500. So like I said, as you are calculating these values, you are obtaining your answer. This is volume in cubic meters per kilogram. But how do we remove per kilogram to kilojoules or per kilogram to cubic meters? The moment we multiply by the mass, it neutralizes everything. So the moment I multiply by the mass, it neutralizes everything to the unit of measurement exactly that I'm given, which is the cubic meters. I have to multiply by the mass. So meaning to say, the moment we multiply this by the mass, it is going to be like this. Let me just put it this way. So this is going to be the dryness fraction. We have it. What was the answer there? I erased. Okay, this is the one here. Sorry, guys. I erased some of these values. 797 times VG. Our VG, this one, it's at this pressure, is the volume of the dry steam there when it is dry. So you take it from the steam table. This is your VG there. The VG there at 1,500. Remember, we are still at 1,500. So your VG is here, 1,500, which is 0.1317. Yes. All right. So this value, we calculated it. I mean, we took it from the steam table, which is 0.1317, which is cubic meters per kilo. That is why you're obtaining your answer in cubic meters per kilogram, which is going to be 0, something like 103 cubic meters per kilogram. But the moment that they want the mass now in kilograms, in cubic meters, I mean, it means the mass has to be eliminated. We have to remove per kilogram. So how do we do that? How are we going to do this? I mean, we are going to multiply by the mass. We are given the mass of this is what? Is 2 kilograms. The moment we multiply by the mass, the kilogram and per kilogram cancels. You are left with just exactly the volume of wet steam, which is going to be 0.206 cubic meters. So that is V wet. I mean, the volume of the wet steam, which is V wet. That's it. The exact volume, not per this unit, no, not per kilogram. All right, no problem. Let's hope we are together then. 3.6, let's see. 3.6, the condition again. The internal energy in kilojoules of the wet steam mentioned in question 3.4, from 3.4, 3. Everything there, it was about wet steam. But they are saying we are supposed to have this internal energy in what? In kilojoules. Meaning to say the mass has to be involved. Remember, we calculated before internal energy in kilojoules per kilogram. It was because the mass was, there was no mass. The mass was not there. Here, the mass is there. So the internal energy formula is not going to change. Remember, I talked about that formula, but I said you work with that formula at a certain condition to say how the steam is considered. As we saw, guys, our formula, let's just gonna win here. Let me just write it here. But we calculated, we talked about this. So I'm not gonna go back to that formula sheet, guys, but this is it. Okay, let me just refer here. This one. So we saw that U is equal to what then? That's 3.6. So we saw that U is equal to P minus so this is enthalpy, sorry, H minus PV. So this, like we calculated in the first place. So this is U2 now because we once calculated a certain internal energy before, remember, when the steam was superheated. Now they want us to calculate another internal energy, but this time the steam in question 3.4, how is it? It is a wet steam. So meaning to say if we are working with the wet steam, this must be H wet. So the formula can be manipulated as H wet minus P, that is the pressure at the second condition, then V is the V wet. So this is P2 times V wet. So as you can see, the language there, just one or two things, but it's only the same thing. When it is wet, what is the internal energy? That's it. So H wet, because of the way that we are given, I want us to be careful there. Because of the way that we are given, the volume that we calculated here, it is cubic meters, not per kilogram, no. So it means if I take this H wet in kilojoules, this one, I'm going to obtain the answer direct in kilojoules. Remember, they want us to have the internal energy in kilojoules, meaning to say the mass is no longer there. So instead of taking us the calculated value where the mass is not involved, let us take this, because here I told you guys already the mass is already here. It's already involved here. The mass is there. Kilojoules, the mass is already there. And it's already kilojoules that we want. So this will be 4,800 minus, this is P2. There is a minus there. That's a minus there. So it's minus P2, then V, which is V wet. So the P2 there is the pressure corresponding when the steam is wet, and that is the pressure that we are when the steam is wet, which is 1,500 into V wet, our V wet in cubic meters. It means we are going to obtain our value, this one. Remember, pressure times volume, we are supposed to obtain kilojoules per kilogram. But because the volume that we are taking is not per kilogram, so it means our answer direct here is going to be in kilojoules. So that is the internal energy in that case. So it's like we are calculating the heat, which is the internal energy. So our internal energy at the second part was going to be 4491 kilojoules. That's it. Just like that. So we have to be careful in our presentations. All right. Then 3.7, I'm sure this one has nothing to do with 3.4. On 3.7, they are saying there we need the enthalpy of a 2,5 dry steam of pressure at 880 kilopascal. The enthalpy for 2,5. So we're given the mass of 2,5 kilograms, but it's a dry steam, it's not wet. The dry steam. So the enthalpy of dry steam is Hg when it is dry. At a pressure of 880, we can have this value. Yes, it's true that Hg can be calculated from HF plus HFG. It's a combination of HF plus HFG. But it's there from the formula sheet, from your steam table. So let's hope I inserted where there's 880. All right, 880 is there, this one. So we need the value of Hg there. What is the part here where there's Hg here, down here? Hg, we already marked this, but around 880. This one. So that is 2,772 kilojoules per kilo. That is the most important part that I want you to learn there is the units. It's kilojoules per kilogram. All right. So you've got 2,772. All right, no problem. So meaning to say here we are going to have our answer as Hg. In actual sense, our Hg was supposed to be 2,772 kilojoules per kilogram. But we are given a mass. So the moment we multiply this by a mass of 2,5 kilograms, it means the per kilogram and the kilogram cancelled. You're obtaining Hg direct in kilojoules, which was going to give us 6,000 930 kilojoules. It's no longer per kilogram. No, it's no longer per kilogram. There are so many questions that we need from this question paper of November 2023 exam. But for now, that's it, guys, from Mason African Motives. Till we meet again. That's 20 marks for that.